I hear that it's always good to just write your own framework because then it's obscure and nobody knows what's actually happening.
Yeah, I mean, that's one approach. How's that worked out for you so far, Nick? What's the URL of your website again?
I did have to remove a Bitcoin miner from there, I'll be honest.
Whoa, how did that happen? That's actually, we got to hear that story.
Bandwidth for Changelog is provided by Fastly. Learn more at fastly.com. We move fast and fix things here at Changelog because of Rollbar. Check them out at rollbar.com. And we're hosted on Linode Cloud servers. Head to linode.com/changelog. This episode is brought to you by Rollbar. Move fast and fix things. Resolve errors in minutes and deploy with confidence. Head to rollbar.com/changelog. Request a demo. Get started today. It's loved by developers, trusted by enterprises, and most of all, we use it here at Changelog. Move fast and fix things with Rollbar. Once again, rollbar.com/changelog.
Welcome to JS Party, your weekly celebration of JavaScript and the web. JS Danger was a huge hit at OpenJS World. There's a link to the YouTube video in your show notes for those who missed it. Next week on the show, I'm joined by Blitz JS creator Brandon Bayer. We dive deep into his full stack React framework inspired by Ruby on Rails. So stay tuned for that one. Right now, Feross is here with Security School. Hey, it's party time, y'all.
All right, welcome to JS Party. So this week we have a very special episode for you where we're going to be talking about security, and we're taking JS Party to Security School. So get ready for some schooling, everybody. So I'm joined today by two wonderful panelists. First, we have Divya.
Hello, hello.
And we're also joined by Nick.
Hoi, hoi.
Great. So excited to have everybody here. So I thought we would start today by talking about one of the coolest security stories in the web security world. It's the story of the SAMI worm, which was a worm that this guy made, and it was one of the sort of early internet bugs related to MySpace, and it's one of the most famous stories in web security. So have either of you heard about this?
I have, yeah. It's pretty interesting.
I haven't.
Oh, okay. So great. You're in for a treat. It's a pretty wild story. So there's this guy, he goes by the name Sammy, and he had made this bug on MySpace where he sort of realized that anyone who viewed his profile could basically insert some code into the part where you write about yourself, the bio section. And so instead of typing about himself, he would include a little script tag. And he realized he could actually cause anyone viewing his profile to friend him. So he wanted to become like the most popular guy in MySpace, get everybody to friend him. And so he did a little sort of write-up while he was doing this. He sort of like blogged, or I guess Twitter wasn't around then. So he sort of had this like little updates that he was writing where he sort of explained what was going on. It's really kind of quite funny to read through. So I thought I'd share some snippets from his sort of journal as he was doing this bug.
But I think that the more problematic thing beyond just friending him is after it would automatically friend you with him, it would post on your MySpace page, "Sammy is my hero." And so yeah, it was just like this virus that went everywhere.
Yeah, actually, still to this day, if you search like "Sammy is my hero," you'll actually find a random, because MySpace is still around, by the way, in case you didn't realize. I actually went and logged into my old profile. Yeah, there's still some random pictures from like middle school Feross or high school Feross on there. But yeah, you'll still find people's profiles that say "Sammy is my hero," because even after all of the aftermath of this, they never managed to fully clean up that string from their database. Let me just share some of the bits from the story. So anyone who viewed my profile who wasn't already on my friends list would inadvertently add me as a friend without their permission. And I can propagate the program to their profile, can't I? If someone views my profile and gets this program added to their profile, that means anyone who views their profile also adds me as a friend and hero. And then anyone who hits those people's profiles add me as a friend and hero, and so on. So as you can see here, it's going to probably not end well. So he started with 73 friends, and that's when he released it. And an hour later, he had received one friend request. So somebody, I guess, viewed his profile and got this code running on their browser, and it caused them to friend him. So not too impressive so far. But then 7 hours later, he checked it again and realized he had 221 friend requests. So way more than he expected. And he was kind of surprised that it worked. So 200 people infected in 8 hours. And so then he was like, okay, cool. So I'll have 600 new friends every day, right?
Mm-hmm.
That's how growth works, right? Except for he didn't realize, it's obviously exponential growth here. So an hour later, he ended up having 480 friend requests. So, oh snap, right? An hour after that, he had 561 friend requests. Now he's getting messages from people who are upset that they friended him and they don't remember adding him. So now people are starting to email him. 3 hours after that, he has 6,300 friend requests. Now he's starting to get scared. So he tries to go and cancel his MySpace account. It's getting out of control. People are messaging him saying that they're reporting him because he's hacked them. And they're upset that his name's listed as in their heroes list on their profile. People are trying to delete him. So they delete him from the friends list, but then they visit someone else's profile and they're immediately reinfected and they add him again. So now he's getting really worried. He's like, oh, snap, this is totally out of control. Okay, 5 hours after that, he goes to his profile again, kind of hesitantly at this point, and views the friend requests and sees that he now has 917,000 friend requests.
Wow.
He refreshes 3 seconds after that. Now he has 918,000 friend requests. Refreshes 3 seconds again later. Now he has 919,000 friend requests. A few minutes later, he refreshes. He has 1,500,000 friend requests.
Wow.
So it's literally going up second by second, right? In less than 20 hours, he hits 1 million users, 1 million friends.
That's crazy.
Yeah, and the crazy part is every single one of these requests is a unique, logged in live user who was browsing MySpace at the time and triggered this code to run on their browser to friend him. Pretty wild, right?
It's crazy. And the weird thing to me is, didn't he get in trouble for that?
Yeah, I think so. Actually, I can't remember the conclusion of this. Did he get in trouble?
I think he did. When I just looked it up, it seemed like the Secret Service showed up at his door.
Oh my God.
But if I remember MySpace correctly, which I may not at all, didn't they encourage you to customize your profile by injecting CSS into it? That was not just like an unknown vulnerability. It was part of MySpace was customizing it to your heart's content. And so I really feel like he shouldn't have been that much at fault. Yeah, it got out of hand, but it wasn't his fault that it propagated like that.
Yeah, I don't think they wanted you to type scripts in. I'm pretty sure they tried to stop scripts, but the CSS and all the other customization, I agree. That was I remember those days. It was really cool. You could try to make your profile stand out, and people learned HTML and CSS in order to make their profile cool. It was a real reason to learn to code. I remember that. Then what happened though? So the story continues actually. So an hour after he hits 1 million friends, he actually realizes that the friend contacts him and says, hey, I can't actually see my profile anymore or anyone else's profile or anything. The site seems to be broken. So messages start appearing on other websites where people are talking about how MySpace is now down for maintenance. Everyone at MySpace is working on getting the site back up. Now he's like, oh snap, should I drive to their office and apologize to them? I think I broke the website. So 2 or 3 hours later after that, the site seems to be back up, but all the code is gone, but the string Sammy is my hero is still on everyone's profiles.
That's awesome.
Yeah, so they probably did some kind of regular expression search or something across their whole database to remove this code and clean up their site. But yeah, do you have any thoughts on why the site went down because of this? You wouldn't think that just a couple, hundreds of thousands of friend requests would cause a site to go down. But yeah, I don't know. I actually they never wrote a postmortem about why that actually took the site down.
Yeah, I don't know. The immediate thing that comes to mind is maybe it's exponentially growing in the number of friend requests, and maybe those rights to the database or something of add friend,
Mm-hmm.
might have something to do with it.
Yeah, a recursive thing or something that just totally, yeah.
Or maybe every time they added him as a friend, they would have to search through all of his friends to make sure that they're not duplicated. There's some kind of OVN operation or something like that.
Yeah.
Or maybe even people who already had him as a friend were still making those requests to friend him. So it was just causing extra requests on every page load, maybe.
Yeah.
So anyway, it's a pretty wild story. So I just like that story because it's a very good intro to what XSS is. The way to summarize it is sort of something that is input from the user gets combined with something that is code from the website itself. And when you're combining user input and you're combining code, it's possible for that user input to be actually interpreted as part of the code rather than as really clearly user input. So this happens a lot in HTML. And in fact, actually, I don't like the name cross-site scripting or XSS because it's actually just a very weird name. What really is going on here is it should be called HTML injection, because really what you're doing is you're somehow causing new HTML tags to get added to a page, when really the site author, the person creating the website, was intending for that user input to be just a string. They're literally, what they were doing is they probably had like a p tag for text, and they were going to paste sort of whatever the user types into the little box for their profile information, right? And instead, the user typed in some HTML tags, and then that got pasted in there, and that became HTML tags that the browser interprets as code to run, basically. And the browser has no idea that text came from the user, because when the server sends the page down to the user, they're sending this combined sort of blob of, it's like sort of a page that's composed of text and content from all kinds of sources, and it comes down as this one unified thing. This is the page, and so the browser doesn't know oh, this came from the user, I shouldn't run it. So that's actually the server's job to make sure that the user input doesn't get treated as code or doesn't get combined into the page in a way that the browser will be confused and think that it's code.
Yeah, I actually have a kind of similar but much smaller scale Sammy style story that I did in college.
Cool, let's hear it.
I was specifically taking a computer security class, but I made a page that I was using cross-site scripting to inject code into the page, and basically what it was doing was it was assuming that you were going to visit this page while you were logged in to Facebook. And so it would actually load Facebook in an iframe, and then it would use JavaScript to keep that iframe always under your mouse just once, so that you click it, and it was specifically clicking in that iframe on the add friend request, to add me as a friend on Facebook back when I had a Facebook account. So it would do that, and then you click, it adds the friend, and then the iframe disappears, and then you can click like normal. So at most you just have one erroneous click that you think, oh, it didn't register for some reason. You click again, and then everything works. And it was for a small site. People who were in that class visited it, but it wasn't open to the wider world. It wasn't like a MySpace where I would have, taken down the internet with that or anything. It was just a couple of people in the class clicked it. But it's kind of using that, plus I think hovering the iframe under there is called clickjacking. So it was using kind of those two combined to exploit that and add me as a friend.
That's super cool. So it was literally an iframe of the Facebook site, and then no matter where you moved your mouse, you made it so that if they clicked, it would click the button you wanted.
Right.
Mm-hmm.
But you made it invisible, so they didn't know that would happen, right?
Yeah, that's the other part. There was I think opacity was set to 0 on it, and so it was just completely invisible. I don't even think that you can do that really with browsers anymore. I think they guard against that a little bit, maybe by not letting iframes be completely transparent, but I could be wrong on that too. I haven't looked at it in quite a while.
Wow, that's pretty wild. It's really surprising that, this must have been pretty early, because that's a pretty basic security thing, is most sites these days that are worried about this sort of thing, or that have any kind of user login, will make sure that they can't be framed. If your site can be framed, then you open yourself up to this type of clickjacking attack, because that means an attacker can just frame your page and then put move you around the page, put you under the mouse of the user, and all these kinds of things. So this must have been pretty early.
This was probably 2006, 2007. So yeah, pretty early on.
Okay, wow, really cool. Yeah, so that's kind of interesting, because both of these things they raise a question about sort of why is the browser allowing this to happen? Why doesn't the browser do something to stop both the SAMI attack and the Nick attack? Because you might think why should a site be allowed to frame another site, or why should a user be allowed to get their code into a site? So I thought it would be useful to maybe go over the same origin policy and just review that before we talk a little bit more about the different types of XSS. So I had a little quiz I wanted to give you guys. So it's quiz time. Even though we haven't even talked about this, I'm going to quiz you already. So I wanted to ask you about the same origin policy. So let's start really simple. So is site A allowed to link to site B? So say we have two different sites. Can site A make a link to site B?
Yes.
Yes. Okay, good.
Yeah.
Divya, is your answer also yes? Okay, good. I know, I'm insulting your intelligence. All right. Is site A allowed to embed site B, in an iframe?
Yes.
I think so.
Yeah. Okay. Yeah. But I guess maybe you were thinking, because there's actually ways for sites to opt out of this.
Yeah, it's like frame busting, right? Is that what it's called?
Yeah. You can do frame busting, which is like where you literally write code to sort of detect that you're not the top frame. And then you can sort of like refuse to load your site or like cause a blank screen to load or something. That way that you can't be framed. Yeah. But the proper way to do that is actually to include an HTTP header that just says to the browser, like, please refuse to put me in a frame. And then the browser can enforce that really perfectly. Yeah. There's actually a research paper that somebody did where they figured out that every single person's frame busting code was actually broken. So there's no way to like correctly like detect that you're in a frame if you're trying to do it with JavaScript, because the outer frame can sort of lie to you about the world or trick you or load you in a certain way. So you actually have to use that HTTP header to make sure that you're not framed. Okay, so next question. So is site A allowed to embed site B and modify its contents? So modify site B's contents?
No.
No. Okay. Intuitively, though, why is that?
They're loading different realms, and you can't access code from a site that's not the same domain and port. And like, I don't know exactly what that's called, but
Yeah. My assumption was, the same. You're allowing it to load content, but nothing else. So you just like pull content and not running scripts or anything like that.
Totally. Yeah. So you can't actually like reach into the page as DOM and change it.
you can though, right? If it's on the same host and port and everything.
Oh, correct. Yeah. That's right.
Cool.
That concept of like host, the protocol, and the port is called the origin. So if two sites have the exact same protocol, so like if they're both HTTPS or both HTTP, that's the protocol. If they both have the same host, so they're both like the same domain name, so example.com or something like that, and they're the same port, so port 80 or port 4000 or whatever port, then if all three of those are the same, then the sites are on the same origin. And so that means they're basically the same, they're the same sort of security realm or security context, and they can do whatever they want to each other. The browser just thinks that they're the same site, basically. Okay, I have a couple more, and then we're going to go to a break. So the next one I have is, can site A submit a form that posts to site B?
Yes.
Yes.
I assume yes.
Is this how Ajax works?
Yeah,
Back
exactly.
in the day?
That's what I assumed.
Yeah, that's right. So that's good. Yep, it totally can. It's kind of weird though if you think about it. Like whenever you go over these things, you wonder like who made all these rules? Like why are certain things allowed? Like why can I embed an image, and like send a form to a site? Yeah, it just seems like this weird collection of like things that are allowed and things that are not allowed. It's really fascinating what ended up being allowed and what didn't. Okay, next one. So can site A embed a script from site B?
I did not think so. That was my assumption. Like, my assumption was that you would pull in the script and then you would have to eval it almost in order for it to run. But I don't know. So, yeah. My answer is, I don't know.
So, Nick, what's your reasoning?
If you've ever seen an advertisement on the web, it's pulling in a script from somewhere, right? Or way back in the day, everybody pulled down the same CDN copy of jQuery and put it in, right?
Mm-hmm. Yeah, so that's a kind of a confusing, the way I worded it is maybe confusing. So really what's going on is like you're downloading the script from another site, but then you're actually running it in the context of your site. So site A can say, I want to load site B's script, but it runs in site A. So really you're just taking like site B's code and you're running it in site A. So you're not actually like getting access to like site B's variables or site B's like data.
Yeah, okay. Then in that case, yes. I think I misunderstood. But yeah.
Yeah. So it's my fault. I didn't explain the question well. But yeah, so scripts are allowed to be executed in different environments. Okay, and then my last question is, so is site A allowed to read data from site B? So I guess I should clarify what that means. Read data means like, could I hit a JSON endpoint and then read the response? Or another example would be, could I embed an image from another site? So could site A embed an image from site B and then look at the pixels or like look at the bytes in that image and, read them?
I would say yes. Yeah.
The answer is yes?
Yep.
Okay. To also clarify, this is by default, so without the site B opting in. Like your answer is yes.
Yes.
Yeah.
Okay.
Well,
That's wrong.
No.
I'm going to stick with yes because I assume that's the case. If it's on the same origin.
Well, it wouldn't be, right? It'd be cross origin, which you can do that, but it's opt in. But then there's also JSON-P is the way I was thinking about getting around that. But site B has to opt into that because they have to understand the JSON-P request, right? So no, you can't.
Right. Yeah. So it's no, you can't. The way to think about this one is just imagine if I could make a request to, let's say like gmail.com / emails.json, and that's going to return me like my inbox, all the emails in my inbox. Right. So it wouldn't be good if another site could make that request and then, read your emails out. So that's going to be blocked. So yeah, I think it's all very confusing about what's allowed and what's not. And it seems like people just sort of figure this out as they use the web more and more. But when we come back after the break, I'll try to explain a little bit about the underlying principles about like why are certain things allowed and why are certain things not allowed, and try to make some intuitive sense of it for everybody. So we will be back after a quick break.
This episode is brought to you by DigitalOcean. DigitalOcean provides worry-free database hosting with their managed databases. If you need to get data in and out of Postgres, MySQL, or Redis, call on the world-class support teams at DigitalOcean and stop wasting time on setup, backup, and maintenance. Get simple, predictable pricing. Get detailed documentation. Get up and running in minutes so you can get on with your business. What are you waiting for? Head to do.co/changelog. Again, that's do.co/changelog.
All right, so welcome back. For this next segment, I thought we'd talk about a little bit about what is allowed by the browser by default and what is not, and how can we intuitively think about that? How can we have a real intuition about whether something is going to be allowed or not? So I think there's two concepts that are really useful to know about in this area. One is this idea of, it's called ambient authority. What that means is the browser will do this thing where if you have cookies for a site, the browser will send those cookies with every single request to that site automatically. So say that you go to log into a page somewhere on some site, you log in. The way that login is implemented is the server sends back a HTTP response to your browser and tags that response with like this HTTP header that says, browser, please set some cookies. And please remember basically this key and this value. And then the browser's job is on all future requests to the same site, it's supposed to attach a cookie header with that same key and value. And this is useful so that you don't have to log in on every single page that you go to on a website. So instead of you repeatedly having to log in to authenticate all your requests, your browser just attaches this cookie, and then the server sees the value of that cookie and then knows that, aha, this is the same person who logged in before. And that saves you from having to like repeatedly type that username and password in on every single page. So that idea is called ambient authority because basically ambiently, sort of automatically and in the background, your browser is just sort of helpfully attaching cookies to every single request that comes from your browser. Whether you know it or not, that's sort of what it's doing. And this model is actually really powerful because it enabled sort of the way we, these modern sites we have where you can log into stuff and you can have this sort of dynamic interaction with a site over time, instead of it just being this sort of completely stateless request response that have nothing to do with each other, right? You can kind of have a session. So it's pretty powerful. But unfortunately, this enabled a bunch of other bad things that we don't like tracking across the web. That's how ads track you, is by giving you cookies. And then also, it enabled a whole bunch of security issues. So the security issues come from, the fact that if somehow an attacker can get your browser to issue a request to a site that you're logged into, then your browser will helpfully attach your cookies to that request. And so even if that request came from an attacker, like an attacker kind of caused your browser to send this request to some site like your bank, your browser is going to go ahead and just add those cookies to the request. And then your bank's going to see this request and think, aha, that's my user. I know who that is. And your bank is going to think that you did that request. So it's actually quite dangerous now. Now we have to really worry about the fact that any random site on the internet might cause our browser to make a request to our bank or to our email provider. And our browser is going to attach our cookies, and then the provider is going to think it came from us. If you think about it, that's kind of what happened in Nick's attack, where Facebook had no idea that this friend request was coming from an invisible iframe that tricked the user. And in the Sammy case, the request to add him as a friend came from some JavaScript code that Sammy wrote. And again, MySpace had no way to know that it was coming from there. And in the more general case, if you think about like a form that we mentioned earlier, that a form can be posted to another site. So that means like in theory, I can make a site that has a form that says, that has like a field for like $1 million and then to Feross. And then I could get you to click that and submit that to your bank. And then if you're logged into your bank in another tab at that time, then that request would include your cookies and the browser would see that you want to send me $1 million, right? That's kind of the problem that comes with the way cookies worked by default. Does that kind of make sense?
Yeah.
Yeah.
It's terrifying.
Yeah. That's one concept that's useful. And then we'll maybe get to the other one later. So I guess more on that. So there's some solutions to this now. Have either of you heard of same-site cookies? Chrome's been making a lot of noise about that recently.
Yep.
I haven't.
So, okay. So Divya, what do you know about same-site cookies?
That it disables third-party usage for specific cookies or something like that. So, yeah.
Yeah, that's basically right. So it basically turns off all the things I just said.
Yeah.
It makes it so that the cookies only get attached by the browser to requests that are coming directly from the site itself. So if you're on like your bank site, that causes some code to run that causes a request to go to the bank, then the cookies will get attached. But if you're on my blog and my website, my blog, and I cause a request to go to the bank, it's not going to include the cookies. So that actually solves a whole bunch of issues. Stuff like cross-site request forgery. That's where like forms get submitted to other sites. That can't really happen. Well, the form can still get submitted, but your cookies won't be attached. So you won't be authenticated and you won't be able to do anything. So that's kind of cool. So we talked about ambient authority. That's the idea where the browser adds these cookies to any request coming from a certain site and going to that same site. And that behavior is really the reason why XSS is dangerous, because you're getting this attacker code getting added to a page, and then that code is taking actions on behalf of a user who's logged in. And the server has no way to tell that request or that behavior is coming really from the attacker's code, issuing actions on behalf of the user. Because from the server's perspective, it just looks like any other request, right? So there's a few ways to try and stop this. And we mentioned one of them already, which was same-site cookies. And another one is, have any of you guys heard of HTTP-only cookies? Maybe your framework provided an option to configure this. I know Express has an option for this, for example. Ringing any bells?
Not to me.
Oh, so if you haven't messed with this option, you might already be using them and not know, because it's sort of the default. This is one of the reasons why frameworks are useful, is they can give you good defaults, so you don't even need to know all these security details that are not that fun.
Is that where you like do the set cookie thing in the header, or am I off base?
Yeah, so
Okay.
that's where you actually would set this option. So
Okay.
when you send the set cookie header to the browser, that's when the browser says, oh, the server wants me to add a cookie.
Yep.
And then in there, you can add a little option called HTTP only. And that's really useful to do. And it's really highly recommended to do for all of your cookies.
Mm-hmm.
So the browser is always going to do its thing where it sends the cookies to the server with every request automatically. But it also does this other thing where you can access the cookies from JavaScript. So if you've ever used document.cookie to see the cookies that are in your browser, if you set the cookie as an HTTP only cookie, that means it's not accessible to JavaScript. It's only sent over HTTP to the server, and that's done by the browser. And so as far as your JavaScript is concerned, that cookie doesn't exist. It's invisible. So that's pretty useful for XSS, because if you think about it, now the attacker's code is running in your site, but there's no way they can see the user's cookie. So it's still kind of bad. I mean, they can still do a lot of destruction by like doing stuff as the user, but they can't steal the cookie and then use it later.
Nice. I did not know about that.
Yeah, so it's pretty useful. I think most frameworks are going to set that by default. That's the thing about this security stuff, right? There's all these like random arcane things you need to know. And so it's really helpful when a framework can just help you do the right thing and you don't need to know about it.
I hear that it's always good to just write your own framework, because then it's obscure and nobody knows what's actually happening.
Yeah, I mean, that's one approach. How's that worked out for you so far, Nick?
Great.
What's the URL of your website again?
I did have to remove a Bitcoin miner from there, I'll be honest. Unrelated to that, it was just a static site, but...
Whoa, how did that happen? We got to hear that story.
I'm sure it was just because I didn't have passwordless SSH set up, like with a key, and I was running on the standard 22 port for SSH, and it wasn't that hard of a password. So, yeah, that's probably why.
Nice. Yeah. So, everybody should try to go to Nick's site after this and see what other interesting security mistakes he's made.
I set up all of that, and I set up IP tables to drop everything except for very explicit ports and things like that. So hopefully it should be good now.
Yeah. Just kidding, of course. Okay. So we do HTTP only cookies. That's great, right? Now, if we get XSS'd, the attacker can't see our cookies, can't see our users' cookies. But there's one other thing we'd like to do, which is like, wouldn't it be great if there's some way to just make it so that when an attacker gets their code into our HTML, that it doesn't do anything. It's completely inert, right? That's actually possible. So this is a thing called Content Security Policy, or CSP. And I have to apologize in advance for all the acronyms because the security world loves acronyms and there's so many acronyms. But CSP is maybe something you've heard of. And it's mostly known for being too complicated, actually, and people are afraid of it and don't seem to want to use it. Mm-hmm. But I'm here to tell you that it's actually great. It can completely solve XSS for you on your site. And basically the way it works is it's a way that you can tell the browser using an HTTP header, you can say, hey, my JavaScript on my site will never do these things. So please, if you ever see it trying to do these things, then block it. And so you can sort of upfront just say, hey, like for example, my site, there should never be code on my site that's going to talk to any of these other domains. You could say, my site only talks to like the GitHub API and to this other API, like maybe Google Analytics or whatever, and no one else. And so if some attacker includes some code in your page and you happen to get attacked in this way, the attacker's code won't be able to talk to their own server, for example. They would only be able to talk to the sites that you specified. And so that completely makes their attack way harder, right? Because now, for example, they can't really exfiltrate the data that they're stealing from your users to their own servers. They're limited to sort of just doing things to the page itself, for example. And there's a whole bunch of different things you can do. It's not just about what servers your site can talk to. It's also things like, you can say like, my site doesn't use Flash, so just don't allow Flash embeds. If anyone's doing Flash, just don't allow it. It's a mistake, right? Or you can say, don't allow media elements. There's no audio on my site. I don't want to allow that entire feature, basically. Or you could say, I don't do inline JavaScript, so I don't have inline script tags. We only have external script tags. So now an attacker can't sneak a little, inline bit of code there onto your site. So that's what CSP is all about. And then the other place you might have seen it is Chrome extensions. So Chrome extensions actually force you to not include inline JavaScript, and they do that with a CSP. So they say, you're going to build your code this way because we think it's safer, and they actually enforce it on your extension using this CSP stuff.
I've encountered CSP a couple of times, just like I am purely from like if I'm on CodePen and doing something and I wanted to get data from like a gist, you can't do that in CodePen because they have a CSP that basically disables the ability to pull content from like GitHub or wherever. And so that's always an issue. It ends up being just problematic because oftentimes I'm like, oh, I have this giant, I don't know, like GeoJSON piece of data in a gist and I want to just pull it really quickly and I can't do that. I have to basically copy it into a CodePen and then embed a CodePen in my CodePen to get the data. And even then, that's like a very roundabout way of doing things. So yeah. You can't just like fetch data externally when using CodePen.
Wow, that's wild.
From the Chrome extension side of it, could you explain that again? Like how it enforces that? Because I feel like I've injected scripts into pages before.
So when you do that, are you injecting a script that refers to a file that's in your like a JS file that's in your Chrome extension? Or are you straight up like putting in an inline script, like where the code is like in the script tag itself?
Like I've injected script tags. I think that's the way that I usually go is like I'll inject a script tag that sets a source and pulls down a script from somewhere else.
Right. Yeah. That would be allowed by Chrome's CSP policy.
Okay.
What they don't want you doing is putting script without the source and just putting like the code in there.
Oh, okay.
So the reason why that's bad is because if you're doing that, then the scope of the variables that you're creating are going to be accessible to the JS that's running in the page itself. Yep. And so if there's anything that you're doing that's like privileged, then now you're potentially like exposing that functionality to like the ads that are on the site and all the other code that's on that site. And so they want it to be like off in its own like separate context.
Gotcha.
Yeah. So that's probably where some people have seen CSP. The other thing you can do with CSP is you can say, like, for example, no evaling is allowed. So if anyone tries to run eval, you can just say, like, don't let that happen, because that's kind of a wild card. We don't know what's going to happen when stuff gets evaled. Eval is evil.
But you can, within Chrome extensions, there are ways in which you can like modify the policy, or like to what extent. Like, isn't there an ability to like do like similar to how in frameworks you would dangerously set HTML? I think in Chrome, don't you have a way of like doing it where they like prefix it with like dangerous or unsafe or something like that, like in your policy, so you can say allow eval, for example? I think
that's possible. Yeah, that's possible.
Yeah.
Are they letting you change the CSP in your Chrome extension?
I'm looking at the extensions docs now, and they say that there's a way in which you can change the policy. Like, obviously you can't do everything, but I think in your manifest.json, you can add content security policy as one of the attributes, and then add like whatever you want to add to it. So I think unsafe inline is one. Whatever else you want it to say, which is like, make sure that this is a thing you can do. I think unsafe eval is also another one. I don't know the extent in which you can do that, though. I think it has to be your code, though. It can't be like, yeah.
If you add unsafe inline or unsafe eval, then you've kind of made the whole CSP not that useful, though, because that's like the main thing you get from it, is that you make it hard to do XSS. But if you allow unsafe inline or unsafe eval, you're basically saying that any scripts that end up in the page are just going to run. So
yeah, I don't know to what extent this, like, if it totally allows you to do anything or if there are restrictions. I have no idea. I just looked at it and like, yeah.
Cool. So yeah, CSP is cool. I have actually deployed it myself on bitmidi.com, which is the site I was working on a little bit last year. And I found that the thing that makes it hard to deploy is you have to really know in advance all the domains that your site is going to contact, because you're including this list. The idea is you're trying to make the policy as restrictive as possible, and then only allow the things that you know that your site's going to do. So, I like blocked Flash, and I blocked, like basically any feature I wasn't using. And then I said, I know that I'm using like Google Analytics, and I'm using, this API or that API, and I allowed all that stuff. And then I disabled a whole bunch of all the other things that I could disable. But the thing that makes it really tricky is that you can have a script that so say I know that I'm using Google Analytics, so I allow that. So now my browser is going to let that load. But then say the Google Analytics script itself injects another script, and that script comes from a different domain that I didn't know about or I didn't allow. Well, then that's going to get blocked and it's going to break. So you have to kind of know, not even just like the things you're depending on, but you have to kind of know the stuff that it might include and the images that it might load the images that it might load from other domains. You have to list all that out. And so it's very fragile in some ways. Like if Google changes their script, then my site will now not allow it to work. Mm-hmm. And so this is why people have been relatively hesitant to deploy CSP in the past.
That seems like a good feature, though, rather than like a problem with it, because I don't know. I feel like Google Analytics, for example, is a well-known, possibly well-trusted source for a third-party script to come from. And so if anything, it would have a list of all of everything that you need to add in your content security policy to make it work properly. Mm-hmm. But it will help you prevent accidentally allowing a third-party script in just because you trusted one source that you thought you could trust.
Yeah, that's a good argument. Yeah, you might argue that if Google changes their script to start talking to other sites, you might want to know about that and have to explicitly allow it before it works.
That's true. It does force you to keep up on the docs of analytics in this case.
Mm-hmm. There's actually an approach now that is in most of the modern browsers that makes this easier to use. And I wanted to mention it. It's called strict dynamic. And it's basically a way where you can say, I trust this one script. So I say I trust Google Analytics. Debatable whether I should do that, but say I do. Then maybe I don't want to have to like figure out all the things that they're going to include. And the other thing that's confusing is maybe they only include certain resources for certain users, right? Mm-hmm. And so now I might not even be able to enumerate all the different domains that it's going to talk to. So maybe I just want to say, look, I trust this Google script. Let it do whatever it wants. Whatever it trusts, I will implicitly trust. And you can do that by saying basically this keyword called strict dynamic. And with that, you can say, the way it works is rather than enumerating all the domains that you're going to load stuff from, you can use this thing called a nonce, where you, in your HTTP response, you say, I'm going to just add this random thing called a nonce. It's just a random string of numbers and letters. It's unique for every request. And then that tells the browser anytime there's a script tag and that script tag says nonce equals, and it's that same nonce, then that means that script tag must have been generated by the server and not by an attacker. So does that make sense? So basically, the server makes up this nonce thing, and then it's like, it tells the browser that in the HTTP header. And then it says, now I'm sending you a page of all these script tags and different things. And all the script tags that the server definitely meant to put there are going to have that nonce equals that same nonce set. But if an attacker managed to get their script tag into the page, there's no way the attacker could know what the nonce was, because the nonce was only in an HTTP header. And the attacker has no way of seeing that because it's different for every request.
That's cool.
Yeah.
I did not know about that.
Yeah, it's pretty cool. So anyway, if you're having trouble deploying CSP, I highly recommend taking a look at that. It makes it like a lot more practical and makes it so that you can like actually like get it right without having to guess and to maintain these like long lists of domains. The other thing I've seen a lot of sites do wrong when they're trying to deploy CSP too, it's pretty funny, is there's sites that are just like end up listing like so many domains in their CSP. They'll even list things like those JavaScript CDNs. They'll let code come from JavaScript CDN. The problem with that is that those CDNs are hosting everything on NPM.
Yep.
So if you're an attacker and you want to run code in this, and you figure out how to get your script tag into this victim website, then all you need to do to run your code is you just put something on NPM, the CDN will host it, and then you can just refer to it, and they're going to allow it. So you can't allow a source where anyone can publish code to it, or else it's not doing you any good. So
these days, it might just be easier to get your malicious code into the NPM module.
Yeah, that's a whole other story though.
Changelog News is the best way to keep up with the ever-changing world of software. We track, log, and contextualize the coolest projects, the best practices, and the biggest stories each and every week. Make changelog.com your daily destination, or hit the snooze button and subscribe to our weekly newsletter that hits inboxes on Sunday mornings. Join more than 15,000 enthusiastic readers. It'll cost you exactly $0, and you can subscribe right now at changelog.com/weekly.
Now we're going to do a little segment where we just share a whole smattering of random security things. We're going to share some security stories, and Divya is actually going to tell us a little bit about one of her favorite security podcasts.
Yeah, so I listened to a podcast called Darknet Diaries. It's really fascinating because in my day-to-day, I don't deal with a lot of security issues as a front-end developer. That's like not something, I think in general, a lot of the times as a front-end developer, you don't really deal with a lot of security things. And so I listened to it. It's kind of a guilty pleasure just to listen to like what happens in the black white hat world. And there's actually an episode in March, I think, where they talk about Sammy. I didn't realize because I have not been updated on listening to podcasts now that I don't go anywhere. It's really cool because you get to hear about different things like security vulnerabilities that you might not have heard of, and just hear the inside story, because it's not just talking about the vulnerability that happened, but it's also the story of like the person, the hacker themselves. And I think it humanizes them, because oftentimes when you read stories about things that are hacked, like for instance, I read Krebs on Security, and Krebs on Security is usually, he's a journalist, Brian Krebs, and he talks about the vulnerability and like sort of the solution, what happened, as well as like the resolution. So there's not a lot of focus on the hacker themselves. And oftentimes, I mean, because he is a security researcher, the hacker is always shed in a poor light. And Darknet Diaries does sort of the opposite, where you empathize with the hacker a little and you sort of feel bad for them and you understand where they're coming from. And you hear the backstory of like how they started, what made them like create a specific bug and so on, which I think are really cool. The other thing that, like I mentioned Krebs on Security negatively, but I also read it quite positively. He posts really frequently. I think the one story that I was really hooked on was when he talked about Mirai, which was like a botnet on the IoT stuff. And it was really fascinating just to read about it. I don't do a lot of IoT work, but he covered Mirai quite extensively, as well as talking about like who the people were and how they created Mirai and how Mirai affected a large portion of the US. And I think in general, like if you read non-security things, Mirai was not talked about. Like no one knew that this was a thing. But in the security world, it was pretty big. So I find that really fascinating to read about. And then the other thing also, I think for us, you mentioned this earlier, is just like vulnerabilities that happen in actual hardware. So because I read a lot of Brian Krebs, I'm paranoid about credit card machines and ATMs. And so one of the things I do, because there's a lot of these skimmers that people add onto the ATM machine. So when you put your ATM card into the card reader, it will skim your number, like any of the information on the top. So people who come to take the thing can grab all of your information and basically clear your bank. And oftentimes they come with a camera as well, so they can read your PIN. So they like look at the card number and they see your PIN. So when I'm at an ATM now, I always cover my number pad and I always pull at the card reader as well.
I do too.
Yeah, because skimmers are usually, they come right off if you pull at them. It's a habit I formed just from reading his blog, because I think there's a large portion of his blog, it talks about a lot of like software bugs, but there's a lot of hardware stuff as well that I didn't even fathom before. So yeah, it's like really cool to just see what's happening in that part of the world.
I think if you read those kinds of blogs for long enough, you'll just become more and more paranoid.
Oh, for sure.
And take more and more precautions.
Yeah.
2FA all the accounts.
Yep.
You know?
Exactly. 2FA everything. And then there's a point in time where I was like, I would put my phone in airplane mode if I didn't need it, just because I didn't want, any like requests going out. And I've been making sure that apps aren't like downloading things in the background unless I explicitly ask them to. So, yeah.
The rabbit hole goes deep.
Yes. I'll soon be wearing a foil hat at some point. Maybe. We'll see.
There's one episode of Darknet Diaries that I really like. I think it's called the Beirut Bank Job, and it's more about physical
Oh, yes. That one was
penetration
so cool.
testing. Yeah. not to spoil it, but they break into a bank in, I think it's Beirut, right? The Beirut Bank Job.
Yeah.
They broke into the bank next door to the one they were supposed to break into. And just hilarity ensues from there. So definitely check out that episode. It's pretty great. And that kind of stuff is really interesting to me. And I have been wanting to get into this more and more. I was actually signed up. I found a team, CTF team, a Capture the Flag team, to take me under their wing and let me participate at a hacker conference. And then COVID-19 hit and I didn't end up going, unfortunately. But I'm looking forward to that next year.
Nice.
I did actually go to DEF CON, though, in 2010.
How was
I
it?
want to say. It was awesome. It was really cool. It's in Las Vegas. I think it was the last year that it was at the Riviera Casino. Anyway, there was some really cool talks there. And two specifically, there was one where a guy wheeled out his own ATM that he bought on like Craigslist. And he showed how he like inserted a thumb drive into it in somewhere that you could totally access if you were just like coming up to one on the street, loaded his own version of the firmware, and then he had it on stage spitting out this fake money that he had printed, just to show how easy it was to get this ATM to spit out money.
Wow.
And then another guy brought up a full ham radio setup, and he used that to spoof an AT&T cell tower. And all throughout the casino that day, they had signs up saying like between 2:30 and 3 or whatever, if you have AT&T, you will not be able to make phone calls, including to 911. And it was because he was running his own tower, and every time you used an AT&T phone, it would go directly to his cell phone and just go to voicemail. And just super cool, awesome. Super scary stuff that people dream up when they have a lot of time like that, which is really cool.
Wow, that is really wild.
When I went there, I bought a netbook because netbooks were a thing at the time. And I wiped it and put Ubuntu on it. And then when I got home, I wiped it again, and I never logged into anything. I just made sure that I wasn't going to end up on their wall of sheep.
Wait, what's a wall of sheep?
If you get hacked at the conference, if they get access to like any credentials of yours, you get put up on this wall. And so you just get made fun of.
That's one of the reasons why I always find DEF CON really fascinating, but I refuse to go to one just because I'm super intimidated that I'll just be like the idiot who doesn't know anything. Just like randomly, I need to pay my credit card bill and then access my bank and then someone will get my information or something dumb.
They have like 2 Wi-Fi networks there, and one is like secured, like the, WPA3 enterprise security. So like your laptop has its own key that connects, that secures the connection to the router. And then they have this other network that's the complete opposite. No password, completely open. If you join it, your computer will catch all the diseases. Like, so I think as long as you don't join that one, I don't know, probably fine. But then I don't know. I guess, I'm kind of paranoid too. Like I'm worried there's going to be some like really terrible bug that somebody there knows about that, just having your Wi-Fi card even like on, having Wi-Fi like just on, they're just going to be able to send a message to it and like own your whole computer. And, I don't know. I don't want to even think about that. So
yeah, I think thinking about wireless and Wi-Fi networks, like one of the things that like from reading a lot of security blogs and being in the sort of educating myself in that realm, I'm more wary of connecting to like open Wi-Fi networks now, just because I'm like, generally speaking, the general populace is not very security minded, so it's probably fine. But you never know, and you just like walk into a coffee shop and you automatically, because I think most phones automatically connect to Wi-Fi networks that are open. And that's like one of the fear that I have, that I'll just automatically connect and then, someone will like send me some spam or a virus or something through that if I make a request elsewhere. So, yeah.
Yeah, man in the middle on those open networks.
Exactly. That's always a fear, which is why I'm like, maybe I should just connect directly, like hotspot, and then use my hotspot.
Yeah, I have a VPN. Anytime I go to a coffee shop, I use that VPN.
Yeah.
Mm-hmm. So Nick, did you have a story you wanted to share, or?
That was my story. I went to DEF CON one time.
Nice.
But you want the sheep, so that's good.
Yeah.
Yeah, I guess I can add a DEF CON story. I was going to talk about a security like bug, but I'll just share a DEF CON story. So I was there one year too. It was really wild to just walk around the different villages they have. So there's all kinds of people doing like lock picking and hacking voting machines and just different little things like that. And one of the ones I went to was social engineering, and they had a guy who was up on stage in a phone booth, and I only caught the tail end of it. So I actually don't know the full context of like what they were doing, but it was so memorable that I want to share it anyway, even though I don't really know exactly what they were doing. I think what they were doing was calling up different companies and trying to social engineer them live on stage in front of everybody. So this guy, like I walked in and I saw a guy in a phone booth, the doors shut so that when they were on the phone, nobody on the other end of the phone line could like hear the audience like laughing and, reacting, but we could all hear. So they were playing the sound from the call out to the whole room. And so we could all listen to the guy's conversation, and we heard him call up. It was some like major corporation that you would all recognize. And he was basically just convincing each person he talked to transfer him to like the next person over. And then he finally just started asking about people's personal information. And the person on the other end was reading out like names, date of births, even social security numbers of like people that were in their system. Like he was pretending he was an employee and was like trying to find out some information about some other employees. And so all this info is just being read out. And, he walks in there with no information about the company at all. And just on the other, after like 15 minutes on the other end, just out comes all this like personal info just by being convincing and just by like talking and saying the right things. And when you see that, it's like you realize like, wow, like our systems are all based on like humans doing the right thing and humans being reasonable. That's like when you hear about the people who get hacked for, when they have their SIM card like swapped out to another phone, like it totally makes sense. Like if you just call up your T-Mobile or AT&T and you just talk to them, there's going to be some other person there. And if you tell them a good enough story, like they're going to be like, okay, yeah, like I'll do that, and then, they'll transfer your number away and then you'll lose all your Bitcoin or whatever. It's pretty wild.
Yeah. SIM swaps are like the worst because it's very difficult to circumvent that. Because it's essentially people trying to get access to a SIM card that's under your name, which then they can access like if your 2FA is linked to your SIM. So it's like send a code through text message, then that's automatically your 2FA is gone. It's just, yeah, which is why I like never do text message auth. I usually have like authenticator or whatever, so it's like separate.
Maybe we should do a whole episode on a future week about all of our security tips for like JavaScript and just in general. It might be interesting. But I think we're out of time for this week. I just wanted to say thanks for joining me, Divya and Nick, and that's it for JS Party this week. So we'll see you all next week. Have a good one.
That's our show. Special thanks to Feross for schooling us, Divya and Nick for enrolling, and you for listening along. Do you have any security tips and tricks up your sleeve? Perhaps a tale of woe that's far enough in the past that you can laugh about it now? We'd love to hear from you. Comment on this episode on changelog.com. There is a link in your show notes for easy click-ins. JS Party's music is produced by the mysterious Breakmaster Cylinder, and we are brought to you by awesome sponsors. Thanks again to Fastly, Linode, and Rollbar. That's it for now. Blitz JS next week.
Oh, the other thing that's dangerous about hot linking, I guess, for images is you could just change the image to like be...
that's exactly. So like my my ex-boyfriend had like an image of like, I don't remember what. He had an image of like the snowman from Frozen, and Cosmo hot linked it onto their website. So like we just changed it to like whatever image we wanted, and it was like, I think it was like 10 things to notice in Frozen, and it was just like whatever. And then they said, and this ice castle, and it was just like a picture of him.
That's so good.
He was like, oh, I'm paying so much for the bandwidth, but it's amazing. It's worth it. I was like, yeah.
Wow. That's actually wild. That's really smart. He could have put an ad in there or something, but instead he chose to share his face with the world.
Yeah.
I like it. Fame.
Yep, on Cosmo.
Did he send it to all of his friends afterwards and say like,
yeah,
okay.
I'll have to find it, but he posted it on Facebook, and it was just like,
I mean, it's better than what he could have put there.
oh, definitely. He could have put anything else there, but just wanted to keep it clean fun.